Okay, we're live.
All right. Hello, everyone, and welcome to Wikimedia Tech Talks. The Tech Talks is a monthly series that showcases speakers from the Wikimedia technical community. Please check out Wikimedia Technical Talks. There's a page on MediaWiki, and you can find more information there to past talks or to propose a talk of your own. And there's a link in the description on YouTube. Today we have Kosta Harlan, a senior software engineer at the Wikimedia Foundation. Kosta will be talking about writing PHP unit tests for MediaWiki. Kosta will give his talk, and then after, he'll take questions from the audience. You can submit questions through the live YouTube stream or through the Wikimedia Office IRC, and I will share the questions with him afterwards. So without further ado, I'll hand it over.
All right, hello, share my screen. Cool. Sarah, can you see the slides?
Yes, I can.
Great. All right. So hello, everyone. Today we're going to be talking about unit testing in MediaWiki with PHP unit. I'm just pulling up trying to make the notes appear properly in the second screen here. 1 second. All right, that's not going to work. You probably can't see this because it's on my second screen, but the notes are resizing in a very bizarre way. So hold on. Let's try this again. Maybe now you can see it. Cool slides. Let's try one more time. Yeah, Sarah, I don't know if you can see this, but it's being very weird. Let me try another browser. Anyway, while I figure out a different browser to present my slides, my goodness. Feel free to go to MediaWiki.org and have a look at the manual on unit testing so you get a sense for what we're going to be talking about today. The thing that you would want to search for is manual PHP unit testing. And that might just a moment while I get another browser, which hopefully shows the slides. Sorry about this. Usually this is the part that fails when you do like the live demo bit, not your slides. So I think this is a good sign. It means the live demo is going to go better a bit later.
Yeah, take your time, Kosta. We can also edit this part out if we need to at the end of the when we put the video up.
All right. Now we're in Google Chrome, which should work with Google Slides, I imagine. Yes, I think this looks more presentable. Okay. Silly me for trying to use Firefox with Google Slides. Anyway, all right. So I'm Kosta. I'm a software engineer on the growth team. That's us on MediaWiki.org. At the foundation, I've been a participant in the Code Health Metrics project, which is overseen by the Code Health Working Group. And there's a bunch of cool initiatives there. This is also MediaWiki.org if you want to look us up and see other things we're working on. Generally, it's improving code quality and code health across projects in the Wikimedia ecosystem. We've worked on various initiatives around code review processes, static analysis, developer education workshops, among other things. And if you're interested to participate in any of that, we'd love to have you join in. And a lot of the work I'm presenting today has emerged out of the Prague Hackathon in 2019. So before we get started, quick shout out to everyone who participated in that. If I have some links at the end where there's specific credits to people, or at least a blog post which gives specific credit to people. But I just wanted to acknowledge up front that a lot of people put in the work to build this infrastructure. I'm presenting about it. So thank you to everyone who's participated in that. Right. So there's an agenda for today for this talk. We're going to talk about some theory for unit testing. Then we will talk about how you run the tests, some examples of writing tests, and next steps for further learning or action. So at a high level, what we're talking about is, what we're going to talk about today is, does your code work the way you think it does? And this is kind of a tricky problem to solve. Like, you write something, you think it does something, and then user tells you later on it's not working the way you thought it does. So that kind of makes sense as like a basic question that you would expect in a talk about testing. Probably less, maybe not as expected, is this other point of can you and or another human understand your code? So like, you write some code today, like tomorrow or a few months from now or next year, are you going to be able to understand it? And also, is your colleague or your collaborator who you've asked to review a patch going to be able to understand it? I think what I'm going to try and get at in this talk is that unit testing is helpful for both of these. Is the code correct? And is the code comprehensible? So that's, I'm going to try and approach this, the next 40 minutes or so, talking about both of those aspects. So, as you saw in the agenda, first we're talking about some like high-level theory background. So first thing to talk about is that there's different types of tests. And if you've seen this type of talk before, you can guess what's coming next. And I apologize, but this is the obligatory testing pyramid slide. There's a pyramid. There were lots of cool pyramids to choose from on Wikimedia Commons. I chose this one. If you haven't seen this before, there's an idea out there in software engineering that a really nicely, like comprehensively tested application can and should have 3 layers of tests. You should have unit tests as the basis of your structure. So there should be a lot of them. It should be the main thing that's there. On top of that, there should be a smaller number of integration tests. And at the top, there should be very few, I wrote E to E because it doesn't really fit there, but that stands for end-to-end tests. I will get into the nuances between integration and unit tests a bit later, but just say a bit about end-to-end tests. The idea is that if you think of your application as this like black box that the tests have no knowledge of per se, that's an end-to-end test is basically saying, okay, I'm going to ask for some page and then I expect to see some results back, and or I fill in this form with these values, I press submit, I should see blah, blah, blah on the next page. Those tests and their framework have no concept of what it is that builds a page or returns a response or anything like that. Yeah, that's all I want to say about that one for now. So yeah, there's this idea that you should have these 3 types of tests, and mostly unit, some integration, a few end-to-end. And the reason is that the end-to-end tests are the slowest. They're also the most brittle. As you make changes, that they require more changes to keep up to date. Not so many integration tests because they're also a bit slower. But we should have lots of unit tests because they're super fast and they can help you with refactoring. Anyway, if you look up this concept later, you'll see lots of people saying it's a great way to look at it, and other people saying this is a terrible way to look at it. I think it's probably somewhere in the middle, but anyway, worth knowing that this idea is out there. And there's also the flip side idea, which is when you turn the pyramid upside down, you have this idea of the testing ice cream cone of doom, where you have a lot of end-to-end tests, fewer integration tests, and very few unit tests. And this is, there's various reasons for this, but part of it is that you end up with legacy code applications that don't have like a really good framework for dependency injection, which we'll talk about later. Also, it ends up being easier to write these kind of higher level tests than to write unit tests, or it's impossible or extremely difficult to write unit tests. So that's that's one reason why this ends up like this. I think MediaWiki is probably more in the maybe the testing hamburger, where there's a lot of integration, a fewer number of end-to-end tests, and then fewer number of unit tests, although it's growing. So we have a lot of integration tests, but a lot of them don't necessarily need to be that way. And it's also possible for us to start writing more unit tests. So I hope to make that process a bit more clear as we go along. So, right, we looked at the ice cream cone and the pyramid. So those are the different types of tests. Looking at the ways to test MediaWiki, if you open up the MediaWiki core directory, if you clone MediaWiki core, there's a test directory, and inside of it, you're going to see various testing frameworks that allow you to test MediaWiki in different ways. So the ways that I know of that MediaWiki is tested, the first one I'm listing out because it's something that we all do intuitively and all the time, and also as part of QA processes, which is a manual testing process of you read what someone wrote in their patch message or in Fabricator, and you check out the patch and you go and you look via your browser, or if it's an API that does something, you use your terminal or whatever. But basically you manually verify, okay, this does what so-and-so said it should do. In terms of the code-driven ways to test MediaWiki, there's Selenium, which is an end-to-end testing framework. There's QUnit, which is a way to write both unit and or integration tests for JavaScript. There's the API testing framework, which is relatively newer to the MediaWiki world. And this is also an end-to-end testing framework, .php endpoint. And lastly, there's PHP unit, which can also be, which is used for both unit and integration tests. And you can even use it for end-to-end tests, confusingly, and we'll talk about that in a second. So, right, the terminology is confusing if you're a newcomer to this, because you see the word QUnit and you think, okay, this is for unit tests specifically, or you see the word PHP unit and you think the same thing. So it's a little bit confusing. Naming things is hard. So let's talk about what PHP unit is exactly. So if you go to their website, phpunit.de, you'll see two sentences. The first one is PHP unit is a programmer-oriented testing framework for PHP. So that's nice. It's a testing framework that we, as coders, will find friendly to us. There are testing frameworks that are geared towards non-coders, for example, and it's written for the PHP language. Great. The second sentence says it is an instance of the XUnit architecture for unit testing frameworks. And I've realized I always kind of glossed over this line and then finally decided to look up what the XUnit architecture for unit testing frameworks is exactly. And so I went to Wikipedia of all places, and I learned that XUnit is the collective name for several unit testing frameworks that derive their structure and functionality from Smalltalk, which is another programming language, SUnit framework. So, okay, it's like a common way of doing things for testing frameworks. And the article says all XUnit frameworks share the following basic component architecture with some varied implementation details. So one, there's a test runner, which is the executable program that you use. In our case, this is found in vendor/bin/php unit. There's a test case, and this is what all the tests are inherited from. The default one in PHP unit is called PHP unit/framework/test case. Then there are test fixtures, and these are preconditions. So you say, before I run my test, make everything in this environment a certain way. And then there's a test suite, and a test suite is where you say this group of tests, this group of like 20, 30, 40 tests, they all have the same, they should all share a certain set of test fixtures. That's what a test suite is. Test execution, I'm reading, sorry, all the implementation details of this framework. Test execution, which says there's a setup and there's a teardown method. So in setup, you do whatever you want to do right before the test runs, and in teardown, you clean up after your mess, basically. The XUnit framework should have a result formatter, which says you should have a certain way of printing your output or returning the output. And they allow for assertions. So you run some code, and then you make an assertion. You say, I expect this result to have happened after I ran this code. Did that happen or not? Yes, here's the XUnit page. Okay, so we've talked a bit about what a test framework is. And by the way, I can't respond to questions in real time, but if you do have questions or comments, please feel free to queue them up, and we will get to them at the end of the slides. Be happy to discuss and answer more. All right, so what is a test? At a really high level, you have some code that says it does something. And a test is a series of actions that exercise this code with various inputs to assert that it works the way you think it should. So I'm going to, since I already had my my presentation mess up in the simple act of sharing my slides, I hope that sharing my IDE is going to work a lot better. So here's this basic example. And again, I'm going to apologize for I always find the really incredibly simplistic examples that you see in testing tutorials to be not that helpful. But of course, here I went and wrote like a really simple example. But I'm going to try and start very simple, make it a bit more complicated, and then we'll start looking at MediaWiki code towards the end. Right. So here's this calculator class. There's a bunch of stuff not implemented, of course, but I wrote this add method, which says it does this. It says it will add two numbers together. It's going to drop non-integer values. Whoever wrote this didn't document these parameters very well. Okay. And they say it's going to return the sum of the numbers. So if you want to test this code, you might have a file that looks like this. So it says use a calculator, declare a new instance of the calculator, get the result from adding, oops, jumped ahead of myself, from adding the values 2 and 2. And if the result is expected, then echo that addition works. Otherwise, say your calculator is broken. So if I run this, I see that the addition works. That's really wonderful. If I say 3 plus 2, and I expect a 4, and I run it again, then I see it's broken. So here's a test. Obviously, it's not part of a test framework or anything, but this is the idea of what you're doing when you're writing a unit test. It's just going to be, all the boilerplate around it is going to look different, but this is the basic idea. And of course, it's not very complicated, but it also gets across this core idea, which I think is important to keep in mind, is that your test is only as good as what you put into it. So in this case, I know 2 plus 2 is going to equal 4, and that's wonderful. But for example, like this class says, okay, it's going to drop non-integer values. I think I already gave away the surprise with my old code, but if I'm passing this and the class is going to drop this empty object that I'm passing in and just have the number 2, I would expect the result to be 2 afterwards. So let's see what happens. Well, PHP throws a warning, but let's forget about that for now. We see the calculator is broken because we expected 2, but we got a 3. And that's because PHP has, when it's trying to add a standard class here, it's converting it to a 1, and then it's adding it to the 2, and that's how you get 3. Again, these are kind of like both basic and contrived examples, but hopefully they demonstrate that like the importance of not just testing the obvious stuff, but also what happens when weird things happen, when weird situations occur in my code. Is it handled properly? Do I get the results back that I think I'm getting? And there's no like magic here of just because you're writing a test that it will somehow cover all the conditions. You're responsible for defining what those conditions are. So that example, yes, that example of the code is the calculator class. Let me bring that up again. This is an example of unit testable code. And what I mean is that there's nothing fancy that happens in the add method. The calculator class and its add function, they don't depend on any other code. There's no connection to a database. There's not network calls. There's not like loading state from application. Given a set of inputs, the output can be known deterministically. And that's a really key attribute and nice benefit of writing unit tests. And that's somewhat different than an integration test, where you've probably seen in Garrett people writing comments like recheck on a patch that has failed, and then the next build succeeds. And the reason is that sometimes the tests have race conditions, or there's some conflict that only happens rarely, but doesn't actually present an issue in the code, but rather in how the tests are written. This is something that's more common in integration and end-to-end tests. Okay, so let's look at some more code again. In a slightly more complicated example. So this one, we have an idea of an election, and you have some candidates, and the candidate who with the most votes is declared the winner. That seems reasonable. So I wrote a application which implements this logic. So there's this class creatively named the election decider, and you tell it about two candidates. You give them their names, our old friends Foo and Bar. You say how many votes they had. You pass them to election decider, which has a method called output winner, and it's supposed to tell us who has the most votes. So let's see what happens if we run election decider. So it says Bar wins the election with 12 votes over Foo, who had 10 votes. So that makes sense. And if Bar has 2 votes and we rerun this, Foo wins the election. That sounds good. And if it's a tie, then we see there's this exception that says it's a tie, and okay, it looks like we should be doing a try-catch statement here in case it's a tie. So that kind of makes, since this method is called output winner and there isn't a winner per se. Okay, so that's cool. Let's look at this class, what it's doing. So output winner, it says if candidate 1 votes is greater than candidate 2 votes, then here's our winner, there's a loser. Else if, do the opposite logic, else say it's a tie. Okay, cool, very simple. Now let's make it a bit more complicated. So let's say your product manager asks you to add a feature that updates the winner calculation logic depending on whether certain democratic norms exist. So yay, the election decider 2020. So here, excuse me, Foo has 5 votes and Bar has 10. And if we run the script, somehow we see that Foo has won the election with 5 votes over Bar, who had 10 votes. What is going on here? And we look at this class, we see it extends the election decider, and output winner starts out looking pretty similar. But then we see that there's this actual winner is determined by calling this validate result function. And what's also worth noting is that validate result is a global function. So it's not part of the election decider 2020 class. If I go look at this function, which again is not part of the class, I can see it's also calling this global WG democratic norms exist. And basically it flips the results so that the loser wins if this flag isn't set. So yeah, so this is getting a bit more complicated. And we can see some problems with that code we were just looking at, which is it's not going to be unit testable because it's calling this global function validate result. It's not part of the class. And it accesses this global variable, which the class doesn't know anything about per se. And if you spend any time with MediaWiki, you've seen this pattern all over the place. You'll see usages of global WG, some variable name, calls to global functions like wf get db, calls to request context get main, calls to MediaWiki services get instance, etc. You can still test it. We have a testing framework for working with a lot of that code and overriding MediaWiki in specific ways to override services and configuration at runtime. But it's pretty complex. The tests are slower to run. In my opinion, they're more difficult to write. Someone please feel free to disagree with me strongly there. And they're more prone to failure, especially in the context of continuous integration, where your tests are now not just running like they were on your laptop, where you have maybe 10 extensions enabled, but in CI where there might be 50 extensions or however many are enabled. And I think readability is also impacted. Like we were talking at the beginning about comprehension of code. Like looking at this code here, there's nothing to tell me other than the fact that we see it's something happening in 2020, so we know it's going to be kind of off the rails to begin with. But there's nothing here to say, actually, there's going to be some weird logic that's going to completely flip the results of what you would expect to happen. And this is one of the problems with this type of code that reaches outside of the class to determine how it should function. It's very hard for me as a reviewer, if a colleague sends me this, to say, I know what's going to happen. In fact, it's impossible to say what's going to happen from just seeing this. So if we want to refactor it for unit testing, it's not that hard. We're going to do something like this, which is create this validator, and the validator accepts this flag for whether democratic norms exist. And here in our setup code, in the wiring code that's putting everything together, here it's okay to do this, democratic norms exist, and I can't type, to pass that in to this class. And then here, that makes it very clear to me that okay, where we're setting everything up, we are accessing this global. We're passing it into the validator. And then this validator is passed into the class. And the class that I rewrote then uses this validator to determine how it should behave. So this idea of passing dependencies in instead of reaching outside is a really key idea in this approach for unit testing, and it's known as dependency injection. So instead of using global WG whatever or WF whatever or request context get main, etc., instead set up your classes to pass in these dependencies, these classes that they need. And you'll see it's really going to help with readability and refactoring, because you're going to be able to see exactly what your class needs to operate. You'll be able to see if your class is way bigger than it needs to be. And we'll talk about refactoring a bit later, but there's a lot of benefits on that front. So we're kind of looping back to the beginning part where we're looking at that pyramid and unit and integration tests. What I'm trying to get across here is that I guess the key dividing line I want to, which can be a little fuzzy sometimes, admittedly, but the key idea is that with unit tests, you want to test small functions in isolation. You're not depending on global state, and you're passing dependencies in. And as a result, you'll get fast test execution and deterministic results. Whereas with integration tests, you're going to get interaction with other parts of the code base. You're going to know about and override global state where you need. And the consequence is that you might have race conditions, and these are slower to run also. So running the test, I'm going to try and go through this pretty quick, especially this first part. So One main advantage of using unit tests instead of integration tests that we can run them without setting up MediaWiki. So they can run in CI before we've installed a database or anything like that. So we get faster results. Our CI is not yet set up for that, but it will be soon because we just merged a patch to do that. And further, the tests will run deterministically regardless of how MediaWiki is set up, like content language, extension, configuration, database contents, whatever. Right, so there's like 3 different entry points here for the command line interface. I'm just going to show very quickly. Like here I am in this MediaWiki directory, and I can run vendor bin. Of course, I've run the wrong commands. Vendor bin PHP unit with this test suite flag and say run all the core unit tests. And there they go. So I'm not going to get into like all the various things you can do with this, but it's worth looking at the help command and seeing all the fun things you can do. There's also in MediaWiki core this composer PHP unit command, which I broke because of how I set up some stuff that I'm going to demo later. Sorry about that. But anyway, it really does work. In fact, I don't even need that test. Anyway, I'm going to skip over this because we're short on time. The point is, if you look in composer.json and you look for PHP units towards the end, you'll see a couple different commands that can execute unit tests, integration tests, code coverage. And then there's also what you probably have read about or used before, which is this file in test PHP unit, phpunit.php. This is actually a maintenance class script that wraps around, it does a bunch of bootstrapping with MediaWiki and then runs PHP unit. I recommend to not use this whenever possible because it does, it ends up setting up a bunch of things with MediaWiki which you may not need or want for unit tests. There's more detail in this task here, T90875. Okay, I had more notes on the command line interface, but I think it's more useful to look at the IDE. Again, this I have to move kind of quickly due to time, but if we look at, what was the example I wanted to use? This one. Authentication, response test. So if you're looking at a class in PHP Storm, you'll see this like play button next to the class. And if you click it, the test will run, which is quite useful. And it doesn't show up in this like full screen mode, presentation mode, but it will also end up in a toolbar at the top. And there's a keyboard shortcut to rerun it, which I think is Apple Shift or Command Shift R. Yeah, Command Shift R on macOS, which is really nice because you can be, you can have a like, maybe you can have your class that you're testing over here, and on the right you can be writing your tests. And each time you make changes, you just run Command Shift R. Your tests run, you keep working. So it's a much more integrated flow. You're not breaking your context all the time. So that's very cool. Other thing that makes running the tests in the IDE much more useful, probably the single most useful thing, is that you can set breakpoints. I do this all the time. You click set a breakpoint, you press on the play button and say debug, and then your test is executing, and you can see the parameters that are passed in, and you can step through everything. It's super useful. And then lastly, you can also see your code coverage reports in line with whatever you're doing. So again, if I'm like working on the class and the tests at the same time, I can run this with coverage. Let's see if it works. And let's say yes, replace the active suites. And if I then scroll in the file, the source file I'm working on, PHP Storm will import the coverage from Xdebug and say, this is the stuff that you've covered with tests. And oh, you didn't catch this, you didn't test this particular path of when an exception is thrown. So you should do that. So that was quite useful. There's some tips also for how to speed this up for extensions. It's documented on the MediaWiki.org PHP unit manual, so I'm going to skip past that for now. Right, so writing tests. I'm going to try and again go through pretty quickly some examples. I can leave at least 10 minutes for discussion and questions. But the first thing I want to say is that when preparing this talk, I realized that actually a lot of what I'm talking about is not MediaWiki specific at all. And basically, if you are looking online, either at phpunit.de or if you search for PHP unit tutorials, pretty much everything you see is going to be directly transferable to writing tests for MediaWiki, which is great because we really don't need to have our own like special MediaWiki way of doing things. And that's a lot of the advantage of moving tests from this integration testing or assumption of integration testing into a unit testing specific framework has enabled that we've stripped away a lot of the like MediaWiki specific stuff, and it's just the classes you've defined, then the tests that you're writing based on PHP unit, like as it is, without any other like magical things happening, which is nice. So I'm going to show this boilerplate extension, which has, if you haven't seen it before, maybe you've cloned it before, this example code, how to do things type of extension. So I've implemented this hook, the before page display hook. And in the boilerplate extension, I've said, if this config variable is set to vandalize each page, then boilerplate is going to add HTML saying boilerplate was here. So in my local settings, I have boilerplate vandalize each page set to true. And if I look at my wiki, I see, yes, the text is there. And if I set this to false, it's not there. Okay, so let's look at how we can test this with a unit test. And I picked this example because hooks, before they had dependency injection, were kind of a tricky place to implement unit tests. It was possible, but definitely a bit more of a hassle. And that's like part of the problem that I think is confusing when you're getting started is that a lot of examples that you see for unit testing are like, okay, there's this function, I'm going to pass in some inputs, and then it will return something, and then I can say, does the return match what I thought? In this case, we're not returning anything. Instead, we're calling this this output page class, which is getting passed through the hook. And we're just calling this add modules or add HTML methods on it. So how do we go about testing that? Let's have a look. So I don't know if I have time to actually type through everything here. So I'll start and then we'll see what happens. So we're gonna like, what we're gonna do is copy and paste to speed things up. But then we're gonna call hooks tests. It's the name of our class. So the first thing you wanna do is you're gonna create a file which presentation mode PHP Storm doesn't show unhelpfully. But yeah, so extensions, boilerplate, you will have a test directory. The test directory has a PHP unit subdirectory. And then inside that, you should add this directory called unit. And that's MediaWiki's cue that we're running a unit test, so don't bootstrap MediaWiki, don't do any of the like setup stuff that integration tests have. And so your file should be called whatever class name you're testing, which in our case, we're testing the hooks.php file, and then the word test with a capital T. And it should extend the MediaWiki unit test case. And that's like, this is basic boilerplate that you need to do. And then you create a public function. And then any test that you want to write starts with the word test. And then some description of whatever you're testing. So it does vandalize. I'll do that to begin with. And this is a test. We can see there's a play button. If I run it, PHP unit says you didn't assert anything. So this isn't a very nice test. If I access this, I will see there's all these, well, not hundreds, but many methods available to me. If I start typing asserts, these are all the assertions that I can use. It's worth exploring this and checking out a lot of these, but I'm just gonna say assert true, true, which is totally meaningless, but just to see, okay, now I have a test, it worked. That's great. Now let's actually make it do something. Actually, before I do that, the other thing that we have to do as part of our boilerplate setup is say which parts of our code does this test cover. So you first at the class level say everything in this hooks test class covers the boilerplate extension hooks class. And then every test method in here is going to cover specific methods in that class. So if I do covers colon, colon, I'm going to see that available to me. And the idea is that like, if I had, maybe I had like 20 methods in this class and one of them called another one, but my test isn't really like checking those specific methods. It just cares about one specific one. You need to tell PHP unit the test really here is only for this one specific method, so it doesn't artificially inflate your code coverage score. So if I want to test this, make a real test, I'm now going to copy paste mode. Sorry. Right, so I'm going to create this configuration. This, if you remember, this was the global boilerplate configuration we saw in local settings here at the bottom. I'm going to say it's true, and then I'm going to create a mock. This is a key like concept in the PHP unit testing world, where you say, construct a fake version of this output page class. So get a mock of it. And now that we have this fake version of output page, so it doesn't actually do anything on its own, it just has like kind of the same outline of what the real output page class has. when this method getConfig is called on it, it's going to return this configuration that we set up here. So this is like this is a pretty key concept here of where you are. It's kind of the equivalent of the election decider code we were looking at, of like you're saying here's my like business logic thing that's going to work in a certain way, like in this example, if I set this to true or something, and then pass that into the code that depends on it, and then it should run in a certain way. That's basically what we're doing here. We're saying create this like fake version of it, define how it's going to react. And then the other point that I was talking about as well of like, how do we test this since hooks.php doesn't actually return anything? Well, you have this handy method here where you can say, I'm expecting that this output page mock is going to be called, that this will happen one time where the add HTML method is going to be called. And it's going to be called specifically with this bit of text. And also that I expect it's going to be called once with this add modules method with these arguments, with this string. So I'm setting up like what I expect to have happen here. And I'm creating a mock of the skin just because this hook on before page display expects that the skin is going to be passed as well. And then this last line is saying, okay, create a new version of this hooks class and call the on before page display method on it. And if I run it, I can see it all passes, hooray. This is the bread and butter basically of unit testing. If you look through the test PHP unit directory and core, you're going to see like lots and lots and lots of variations on this. You'll find it can get unwieldy if you are doing stuff in hooks, which can often have like a single class like output page that will get the context and get the config and get, get the language or whatever else your code might be doing. But as you write smaller and smaller classes and smaller methods, you'll find that setting up these dependencies becomes less of a hassle. And especially if you start using the like service wiring for your extension, you'll find that it becomes a lot easier to write these unit tests in like a less verbose way. Right. I'm going to leave a little bit of time for questions. I'm going to move on from this example right now. We didn't talk about data providers. There are some examples. Maybe I'll show some of that quickly towards the end. So very quickly, when should you write tests? Test-driven development, also known as TDD, is a thing. The idea is that you write your tests, then write the code that passes the test, then continue that cycle until your software meets the project specs. In my experience, it's really hard to do and tedious, but other people love it. So if you love it, I think it's great. I have a hard time doing that. I also think there's kind of the opposite end of the spectrum where you write your application code and then at the very end, or even in a separate patch, you go back and you write unit tests. That also doesn't feel especially productive. It's okay, but it's maybe not so good. I think in between both of those extremes is this idea of that I'm not going to take credit for, but I couldn't find the citation for. It's to treat your unit tests like, well, now I forgot how you pronounce this word, but pythons. But these things that climbers use to ascend a difficult rock face, and you hammer them in, you make some progress climbing up the wall, Maybe you need to climb back down a little bit and go a different way. It's okay, you remove them, you go the other direction. And I think unit tests can be really useful like this as you're writing code. As you get to certain stopping points, say, okay, this class does what I thought it would do. I've written the tests to prove it. I've tested the edge cases. I'm going to continue building off that to the next phase. And this really makes refactoring also much easier because you have this confidence that as you delete code, as you rename methods, move stuff around, that you know I have this whole set of tests that will back me up and have my back. So Sarah, I think this is the cue for you really quick if you want to, if you see questions to bring them in because we just have a few minutes left. But next steps, if you're new to this or even if you're not but want to go into more detail, test/PHP unit/unit and MediaWiki core has loads of examples. You can. There's also, if you want to improve the infrastructure, there's this task, this project in Fabricator. I've been working on updating the PHP unit testing manual to basically make tech talks like this not needed. Help is wanted there. There's a lot to do. The Code Health Developer Education Workshops are ongoing. There's this link here if you want to check that out. And we're also on Wikimedia Code Health on IRC if you want to reach me, or if you have questions about unit testing or anything like that. So say thank you. And Sarah, if you have questions or comments you want to read out, please do. Otherwise, I'll try and show a data provider example in the meantime.
Cool. We have just a few minutes, but we did have a question come in from the live stream from Jay. It came in during the demo, and the question was, what is the method to mock admin user?
So that's a good question. So there's in the I didn't show this in great detail, but there's this integration test case, which a lot of our tests extend. And this does have a method like, where is it? Get test user. So if you're writing an integration test case, and those would go in your extension or in core under tests/PHP unit/integration/name of your test file, and you extend this integration test class, then you can write code which does get test user or get test sysop or whatever. And this actually like creates a real user in MediaWiki in a database with all the like heaviness that's involved in that. If you're writing a unit test and you want to see what happens for a user in a certain situation, you instead do something like user mock equals get mock builder of the user class. And you would get the mock. And then if there's certain things that your code does, depending on whether the user is like an admin or whatever, you would say this method, I don't know if this method doesn't exist on the user class, but whatever, will return that kind of thing. So that's how you would mock a user, and then wherever your code expects a user class, you would pass in this user mock and use it that way. Are there other questions?
Awesome. I don't actually see any other questions on the live stream or on IRC. We are just about at time. So one thing that I'm thinking we could do is if folks have questions afterwards, we can collect those and we can send those to you. Would that work for you, Kosta?
Yeah, sounds great.
Okay.
Yeah, or on the IRC channel also is good, or please feel free to write questions on the manual of unit testing on MediaWiki.org.
Definitely. Yeah. And yeah, feel free to ask those questions in the IRC office channel. Although the comments on the YouTube, or the kind of the sidebar comments on the YouTube stream, the live ones stop at the end of the talk, you can still leave comments underneath the stream as well. So we can check the comments thread too from here.
Cool.
So yeah, we are just about at time. So I just wanted to thank you, Kosta, for giving this talk. And then, oh, we have one more question. I think we can, do you mind going over one more minute?
Yeah, sure.
Okay. This comes from the live stream as well. The question is, could you talk about setting up many tests to run together?
Okay. Is there more detail for that, or that was the?
That's pretty much the detail.
So if you, like in the IDE, if you want to run many tests together, I've actually, now I'm looking at it, in the IDE, I'm always using like just on a specific class. So this default preferences factory test class has, oh, this is an integration test case, sorry. Let's go back to our authentication response test. So this one has one, also not a great example. So this is a class with one test method. Let's see if I can find an example. But basically, if you click this play icon next to the class, it's going to run every test which is listed within that, every like test method within that class. So it runs those all together. There's also a way that you could say to run like all tests for a particular directory or extension. I need to make this screen a bit smaller, I think, in order to see a more normal version of PHP Storm. 1 second. So here, like, if I go back to this test, I press play. You see here at the top, there's this little bar, and this is a run configuration. If you click on this, you have the ability to say, like, create a configuration, and you pass it as scope. So you could say, actually, just run all the tests in a particular directory, or you have some other options to use a configuration file or whatever. It's quite powerful. Also lets you determine whether the test is running on your host system PHP, or if it's running in like a Docker container, if you're running MediaWiki Docker, if you're running Vagrant, that kind of thing. So definitely, as you explore this, check out the edit configurations, and hopefully that would answer your question.
Awesome, thanks, Kosta. So what we'll do is, if there are folks in the call that still have questions, or you're watching this afterwards, do send questions through the YouTube page, or through IRC, and we'll get those to Kosta to answer. So I just want to wrap up by saying thank you so much for giving this talk. I know it was a long time coming, and I'm really glad that you were able to join us. So I just wanted to thank you. And then I also want to thank Emerald for doing the AV on this talk as well. This wouldn't be possible without the great AV folks that helped to make this happen. And this is actually our last talk for the year. So we'll be returning in 2021. So hope to see everybody then. All right.
All right. Thanks, Emerald. Thanks, Harlan.